Good afternoon, everybody. Today we are going to discuss limits and continuity. Weightage of this chapter is 2 4-mark questions and 2 2-mark questions. Limits and continuity. So in this 2 2-mark questions and 1 4-mark question. The total weightage is 8 marks. First, we'll start with the formulas of this chapter. Basic formulas are there. Limit extends to a. X to the power n minus a to the power n by x minus a is equal to n into a to the power n minus 1. N into a to the power n minus 1. If both the powers of numerator are same and the basis as it is in the denominator, then the formula is n into a to the power n minus 1. Limit x tends to 0. Sin x by x is equals to 1. Suppose if you have limit x tends to 0, there is a coefficient like sin ax by x. X must be same. Apart from x, whatever the value you have, that is the answer of that value. So sin ax by x when limit x tends to 0 is equals to a. In the same way, limit x tends to 0, tan x by x is equals to 1. Limit x tends to 0, tan ax by x is equals to a. So these are the main formulas which we use here. Apart from this, there are many formulas here, but generally these are the most important ones. Limit x tends to 0, 1 plus x whole to the power 1 by x is equals to e. Limit x tends to 0, 1 plus 1 by x to the power x. This is also e. Observe the formulas, how we are differentiating them. Next, limit x tends to 0, e power x minus 1 by x. E power x minus 1 by x is equals to 1. Limit x tends to 0, a power x minus 1 by x is equals to log a. So these are the main 9 formulas we will be using here. Just practice them as it is. Now we'll move to directly question. Is okay. We'll move to the next 4-mark question. The question is like this. Show that f of x is equals to cos AX minus cos BX by x square if x not equal to 0, half of b square minus a square if x is equals to 0, where a and b are constant, is continuous at 0. Is continuous at 0. Is continuous at 0. Means by taking limit x tends to 0 f of x, if you get that value is equals to f of 0, then directly we can say that it is continuous at x is equals to 0. Solution. First take the given value. Given f of x is equals to cos AX minus cos BX by x square if x not equal to 0. Next one, half of b square minus a square if x is equals to 0. This is the question, is given data. Now we have to prove it is continuous. Given that it is continuous at 0, that we have to prove. So limit x tends to 0, f of x value find out. Is equals to limit x tends to 0, f of x value function what is given? Cos AX minus cos BX by x square. Generally, when limit question is there, wherever x is there, we will substitute. If you substitute cos 0 minus cos 0 is 0 by 0 square. So getting 0 by 0 form. This is indeterminate form. We are not supposed to get 0 by 0 form in limit. For that, we have to simplify. Numerator is in the form of, we have a formula, cos C minus cos D. Numerator is in the form of cos C minus cos D, trigonometry. What is cos C minus cos D? Minus 2 sin C plus D by 2 into sin C minus D by 2. By applying this formula, we have to simplify the question. Cos C minus cos D is equals to minus 2 sin C plus D by 2 into sin C minus D by 2. Now come on. Apply the formula. Limit x tends to 0, f of x is equals to limit x tends to 0 as it is. Here cos C minus cos D is minus 2 sin C plus D, that is AX plus BX by 2 into sin C minus D by 2, AX minus BX by 2, whole divided by x square. Now, limit x tends to 0, minus 2 as it is, sin, from AX plus BX take x common, a plus b by 2 into x. Right, limit also separate. Limit x tends to 0. Here also take x common. So we will be getting a minus b by 2 into x. Denominator x square is there. So write 1x to first term and write 1 more x to the second term. Now you can observe the formula. It is in the form of limit x tends to 0 sin AX by x. Limit x tends to 0 sin AX by x is what? A. By applying this formula, So this step what we get is equals to minus 2 right outside. Limit extends to 0. Sin a plus b by 2 into x by x. Value is just write x coefficient a plus b by 2 into here also limit extends to 0. Sin a minus b by 2 into x by x is a minus b by 2. Here 2 and 2 getting cancelled. Minus as it is. A plus b into a minus b. A square minus b square by 2. We can write this as, if you take minus inside, first b square will come. B square minus a square by 2. Now next step, what can we write here? This will be b square minus a square by 2. You can write one more simplified step here. So here, this can be written as half of b square minus a square. What we have taken, limit extends to 0, f of x we have taken, is equals to what we got, half of b square minus a square. If you observe in the question, half of b square minus a square is given as what? Half of b square minus a square is f of 0. So we can write is equals to f of 0. So limit extends to 0, f of x value, we got it as f of 0. Therefore, what is the conclusion? F of x is continuous. F of x is continuous at x is equals to 0. If you get both are equal, then only you can write this conclusion. Sometimes they may not equal. So we have to write f of x is discontinuous or f of x is not continuous when x is equals to 0. Depends on the answer, we have to give the conclusion. So this is how the question goes. Just check once again. Two formulas we applied. One is cos C minus cos D. The other one is sin AX by X. By applying these two, we are getting, it is continuous. Similar kind of questions we have. Move to the next one. Question number 2. If f is defined by f of x is equals to sin 2x by x, if x not equal to 0, 1 if x is equals to 0. F is continuous at 0. F is continuous at 0. Means he is asking us to verify whether it is continuous or not at x is equals to 0. Solution. First take the given f of x value. F of x is equals to sin 2x by x if x not equal to 0 and 1 if x is equals to 0. So we have to check limit extends to 0 f of x. Limit extends to 0 f of x value we have to find out. So limit extends to 0, f of x means what is given? sine 2x by x. In previous question we discussed. It is in the form of limit x tends to 0, sine ax by x is equals to a. So by using this formula, limit x tends to 0, sine 2x by x, what we get? 2. So limit x tends to 0, f of x is equals to 2. But in the question, at x is equals to 0, f of x value how much is given? 1. But it is not equal to f of 0. Therefore, what is the conclusion here? F of x is not continuous. F of x is not continuous when x is equals to 0 or at x is equals to 0. Like this, we have to do this. Next. Question number 3. Here x not equal to 0 is given, x is equals to 0 is given. So we did the procedure like this. Next question. Question number 3. Check the continuity of the following function at 2. Check the continuity of the following function at 2. The question is f of x is equals to half of x square minus 4 if 0 less than x less than 2. 0 if x is equals to 2. Two minus 8x to the power minus 3 if x greater than 2. This is the question. So we have to check the continuity when x is equals to 2, he is asking. So if you observe, x value less than 2 is there, x value is equals to 2 is there, x value greater than 2 is there. When you have less than and greater than kind of question, we have to use left hand limit and right hand limit concept here. The solution goes like this. First given f of x is equals to, take the question as it is, 1 by 2 x square minus 4 if 0 less than x less than 2, 0 if x is equals to 2, 2 minus 8x power minus 3 if x greater than 2. Now, left hand limit, we write it as LHL, left hand limit. Left hand limit means at x is equals to 2, we have to find out. So it gives negative value. Left hand means negative side. So limit x tends to 2 minus f of x value we want. So limit x tends to 2 minus means x value is less than 2. Less than 2, where it is? Here it is. The first term, half of x square minus 4. Now, wherever x is there, put 2. This minus indicates only to take less than or greater than concept. So now wherever x is there, put 2. When you are substituting 2, we have to remove this limit term. Half of 2 square minus 4. So 4 minus 4 is 0. 0 by 2 is equals to 0. So left hand limit, we got it as 0. Next. right hand limit we have to find out. A right hand limit. So right hand limit means how the limit changes. Limit x tends to 2 plus. X tends to 2 plus f of x. So that is limit x tends to 2 plus. 2 plus means when x is more than 2. 2 minus 8x to the power minus 3. So now substitute. One more step will simplify. Limit x tends to 2. 2 minus 8 x to the power minus 3, write it in the denominator. It is x cube. Now, limit x tends to 2. Wherever x is there, put 2. It is 2 cube. So, limit x tends to 2. 2 minus 2 cube is 8. 8 and 8 get cancelled. So, we are getting 2 minus 1. Limit x tends to 2. 2 minus 1 is 1. There is no x term to substitute the limit. So directly you can write it as what? 1. Now observe. Left hand limit we got it as 0 and right hand limit we got it as 1. So here what we have to write? Therefore, left hand limit is not equal to right hand limit. So conclusion, f of x does not exist when x is equals to 2. F of x does not exist when x is equals to 2. So like this, you have to give the conclusion. If suppose if you get left hand limit and right hand limit is same, then you have to say LHL is equal to RHL, f of x is continuous at x is equal to 2. And here again you have to check when x is equal to 2, the value also supposed to be same. Then you can write it as continuous. If you have any doubt, you can drop the message. Simple question. Try to understand the question. Continuous at what value he is asking. So with respect to that, you have to proceed the solution. Next question. Check the continuity of the given. Check the continuity of the given function. Continuity of f given by f of x is equals to x square minus 9 by x square minus 2x minus 3 if 0 less than x less than 5, 1.5 if x not equal to 3. At the point 3, so we have to check the continuity at the point 3. We have to check the continuity when x is equals to 3. Solution. Go to the question. Given f of x is equals to x square minus 9 by x square minus 2x minus 3 if 0 less than x less than 5 and 1.5 if x not equal to 3. Now, limit x tends to 3, f of x we have to find out. So limit x tends to 3, f of x value what is given? X square minus 9 by x square minus 2x minus 3. Generally what we think, wherever x is there, we substitute 3. Substitute 3 square, 9. 9 minus 9, 0 we are getting. In the same way, denominator 3 square minus 2 into 3, 6 minus 3. So denominator also 9 minus 9, 0. 0 by 0, we are not supposed to get. So we have to simplify the given statement. You can go for the factorization. Limit x tends to 3. X square minus 9. We can write x plus 3 into x minus 3. By factors of x square minus 2x minus 3. So we can write x minus 1, x plus 1 into x minus 3. Everybody knows how to find out factors. If not, I will show you here. X square minus 2x minus 3 factors. Minus 3 factors are 3 ones are 3. Minus 3 plus 1 is minus 2. So x square minus 3x plus x minus 3. Take x common, x minus 3. Take plus 1 common, x minus 3. Again common, x minus 3 and x plus 1. So like how you have to solve. Now substitute the factor terms here. X minus 3 getting cancelled. Limit x plus x tends to 3. X plus 3 by x plus 1. Substitute wherever x is 3. 3 plus 3 by 3 plus 1. It is 6 by 4. 6 by 4 means 3 by 2. 3 by 2 is nothing but 1.5. In the question, when x not equal to 3, we got what? 1.3 is given directly. So what is the conclusion here? It is when x is equals to 3, we got 1.3. Therefore, the conclusion is, you can write this is f of 0. So limit x tends to 3, f of x value is equal to f of 3 we got. So it means f of x is continuous. F of 3 value and f of x value is getting same. Therefore, f of x is continuous when x is equals to 3. F of x is continuous when x is equals to 3. Once again, come to this question. We have to check the continuity at the point x is equals to 3. So take the question. If we substitute directly x is equal to 3, we are getting 0 by 0 form. It is indeterminate form. For that, we have to find the factors, or we have to go for the simplification form. So x square minus 9 can be written as x plus 3 into x minus 3. And denominator is in the quadratic. So write the factors x plus 1 into x minus 3. Both x minus 3 get cancelled. Substitute wherever x is there 3. So 3 plus 3 by 3 plus 1. It is 6 by 4 is nothing but 1.5. This 1.5 value is given in the question as f of 3. Therefore, limit x tends to 3, f of x is equal to f of 3. So we can say that the conclusion, f of x is continuous when x is equals to 3. So like how you have to go this. If you have any doubts or any questions, you can drop your message. तो वो लोग म्यूट निकाल देना ना वो चैट. Next question. Next, one more. Find real constant of A and B. Find real constant of A and B. So that the function f is given by f of x is equals to, there are so many terms in this question, f of x is equals to sin x if x less than or equal to 0, x square plus a if 0 less than x less than 1, bx plus 3 if 1 less than or equal to x less than or equal to 3, minus 3 if x greater than 3. Is continuous on R. Is continuous on R. F of x, so many terms are given. But question, it is continuous on R. R means what value we are supposed to take? If you observe, in f of x, it is related to 0, it is related to 1, it is related to 3. So by taking these 3, 0, 1 and 3, if we prove it is continuous, then we can find out the values of a and b easily. So for that, the solution is given. F of x is equals to sin x if x less than or equal to 0, x square plus a if 0 less than x less than 1, bx plus 3 if 1 less than or equal to x less than or equal to 3, minus 3 if x greater than 3. The question is attached to less than and greater than. So immediately what we have to do? We have to check for left hand limit and we have to check for right hand limit. Given f of x is continuous on R. This sentence we have to use here. Given f of x is continuous on R. Continuous on R. So left hand limit continuous, when we say left hand limit is equals to right hand limit. At what point we have to take left hand limit? So limit extends to 0. Left hand limit means limit extends to 0. Limit extends to 0. Left hand limit means 0 minus f of x is equals to limit extends to 0 plus f of x. Now, limit extends to 0 minus f of x. When x less than 0, its value is sin x. So limit extends to 0. When you are substituting, you can remove minus. Limit extends to 0. X less than or equal to 0 value is sin x is equals to limit extends to 0 plus f of x. When x greater than 0, it is x square plus a. So limit extends to 0, x square plus a. Now substitute limit extends to 0, sin x is sin 0 is equals to 0 square plus a. We know sin 0 is 0 is equals to a. Therefore, a value is 0. This is one value. Totally, we have to find out two values. One is a, the other one is b. By taking f of x is continuous on R, that is f of x is continuous at 0. We got a value is 0. Next. Also, f of x is continuous on R. F of x is continuous on R. So take another value of f of x. So left hand limit is equals to right hand limit. Left hand limit, what we have to equate? limit extends to which one we can take? We can go for 3. Limit extends to 3 minus f of x is equals to limit extends to 3 plus f of x. Extends to 3 minus f of x means which value we have to consider? Limit extends to 3 minus means x less than 3. X less than 3, the value bx plus 3 is equals to limit extends to 3 plus. 3 plus means greater than value. It is how much? Minus 3. Now wherever x is there, substitute. So 3b plus 3 is equals to minus 3. 3b is equals to minus 3 minus 3. 3b is equals to minus 6. B is equals to minus 6 by 3. 3 ones are 3 twos are. So we got B is equals to minus 2. So overall conclusion, A is equals to 0 and B is equals to minus 2. This is the final answer. One more question. If it is question, show that continuous, we are taking LHL is equal to RHL. Suppose if there is an unknown in the question, like K value, find K. F of X is continuous on R, find K. That R value we have to see by considering the value in the question is given. So next question. F is given by f of x is equals to k square x minus k if x greater than or equal to 1. And 2 if x less than 1. Is continuous on R, then find K. Is continuous on R, find K. Important question. Solution. F of x is equals to k square x minus k if x greater than or equal to 1, 2 if x less than 1. This is given. It is clearly giving that f of x is continuous on R. So since f of x is continuous on R, when we say it is continuous, when LHL is equals to RHL, like left hand limit is equal to right hand limit. So limit extends to, there is only number 1. So left hand limit means limit extends to 1 minus f of x is equals to limit extends to 1 plus f of x. So limit extends to 1 minus f of x. 1 minus means when x less than 1. It is 2 is equals to limit extends to 1 plus means when x more than 1. It is k square x minus k. Substitute wherever x is there, the limit. Left side, there is no x value. Directly we can take 2 is equals to right side. K square into x is 1 minus k. Take k2 to that side. K square minus k minus 2 is equals to 0. Quadratic equation. 2 ones are 2. So minus 2 factors are minus 2 and 1. K square minus 2k plus k minus 2. Take k common. K minus 2. Take plus 1 common. K minus 2 is equals to 0. Again, both of them k minus 2 common into k plus 1 is equals to 0. K minus 2 is equals to 0 or k plus 1 is equals to 0. From here k is equals to 2. From here k is equals to minus 1. Therefore, k is equals to minus 1 or 2. So like this, we have to continue. Sir? One last question of this chapter, of this concept. Check the continuity of the function f of x at 192. Check the continuity of the function at 192. So f of x is given as x plus 1 if x less than or equal to 1. 2x if 1 less than x less than 2. 1 plus x square if x greater than or equal to 2. Check the continuity at 192 he is asking. So, given f of x is equals to, take the question, x plus 1 if x less than or equal to 1, 2x if 1 less than x less than 2, 1 plus x square if x greater than or equal to 2. First we'll check when x is equals to 1. Take left hand limit. Limit x tends to 1 minus f of x. Can be written as limit x tends to 1. 1 minus means less than. It is x plus 1. Wherever x is there, put 1. 1 plus 1 is 2. Simultaneously find out RHL. Limit x tends to 1 plus f of x. So limit x tends to 1 plus f of x. When x greater than 1, it is 2x. So substitute wherever x is there 1. 2 into 1 is 2. So got left hand limit is equal to right hand limit. So LHL is equals to RHL. We'll write conclusion at the end. Next, when x is equals to 2, left hand limit. Limit x tends to 2 minus f of x. So limit x tends to 2. 2 minus means when x less than 2, the value is 2x. Substitute the limit, 2 into 2, it is 4. Now find out RHL. Limit x tends to 2 plus f of x. Limit x tends to 2. 2 plus means x more than 2. It is 1 plus x square. So 1 plus 2 square, that is 5. Here, left hand limit is 4 and right hand limit is 5. Are they equal? They are not equal. So left hand limit is not equal to right hand limit. It means it is not continuous when x is equals to 2. But f of x is continuous when x is equal to 1. Both together you have to write. Therefore, f of x is continuous. F of x is continuous when x is equals to 1. And f of x does not continuous, or f of x is not continuous when x is equals to 2. So like this, we have to give the conclusion. Some more questions are also is there. So you can practice by seeing these examples to get the better marks. Tomorrow we'll discuss some more questions of limits and continuity, which are very short questions. With this, I am concluding today's class. Thank you.